exercise 11.3. To derive this exercise, we need this much formulas. These are not this much formulas. These are the important notes we need to know to derive this exercise. The first one is P of A less than or equal to x less than or equal to b. We can write as integration of a to b f of x to dx. Very, very important. P of this is one, this is another one. This we take lower limit, this one is upper limit. Lower limit by upper limit, lower limit, upper limit, f of x to dx, f of x to dx. Probability, P stands for probability. Probability of a less than equal to x less than or equal to b, we can write as a to b integration of f of x into dx. If f of x is a probability density function, this is called probability density function. You can simply say PDF. PDF is nothing but probability density function. If f of x is a probability density function, it should satisfy two conditions. If f of x is a PDF, probability density function, it should satisfy two conditions. What is first condition? F of x should be greater or equal to 0. The f of x, the function, the given function should be greater or equal to 0. It can be 0 or greater than 0. Next one, minus infinity, integration of minus infinity, f of x dx should be 1. If f of x is a PDF, it should be satisfied two conditions. What is the first condition? F of x is greater or equal to 0. The second condition is integration of minus infinity, f of x into dx. What is the value? Value should be 1. If f of x is in PDF, two conditions should be satisfied. F of x should be greater or equal to 0. What is second condition? Integration of minus infinity plus infinity, f of x dx is equal to 1. Next, distribution function. We can say distribution function or cumulative distribution function. You can say two ways. One is distribution function and another one is cumulative distribution function. We can say simply, we can say caps f of x. That is caps f of x. This is small f of x. That's the difference between small f of x and caps f of x. This caps is nothing but a function. This f is nothing but cumulative distribution function or distribution function. So, f of x, Vidyasagar's formula, using this formula, we are going to derive nearly 6 to 7 sums, very, very important sums, 6 to 7 sums. In previous textbook, there is only one sum using this formula. But in this new textbook, we have nearly 6 to 7 sums. So, these sums are very, very important. This is a cumulative function, f of x. We can write p of x less than or equal to x. F of x is equal to p of x less than or equal to x. Integration of minus infinity to x, f of t into dt, f of t into dt, minus infinity to x, f of t into d. Very different formula. Caps f of x is equal to p of x less than or equal to x, integration of minus infinity x, f of dt. This is another formula, f of x. There is another formula, f of x is equal to. Where is the formula, f of x? So, see, I will say, this f of x used here also, I will say afterwards. F of x is equal to p of x less than or equal to x, integration of minus infinity x, f of t into dt. If continuous, we have studied in exercise 11.4 what is my continuous, what is my discrete. For example, the given values f of x is equal to, in previous we have learned f of x is equal to 1 and f of x 0 when x is equal to 1, 2, when x is equal to 4, 3. This called x is equal to 1, x is equal to 2. These are not given in the intervals. Suppose this is called discrete, this one is called continuous, nothing but 3 minus x. When interval is 1 is less than equal to 2. This is nothing but 4 minus x. When interval 3 less than x less than 4. These are given in the intervals. These are given in the intervals. This is called continuous. This is called discrete. This is called discrete. This is called continuous. These we are studying in exercise 11.4. This will study the exercise 11.4. This is also f of x, this is all f of x, this is a discrete, this is a continuous. See here, in continuous random variable, p of x, p of a less than equal to x less than or equal to b, we can write as, see, a less than equals less than or equal to b is equal to a less than equal to x less than b, p of a less than x less than b. This equal is given is never value. We can write as we needs in continuous random variable in here, this side. This one we don't need to worry about less than or equal to. This is the main thing we need to learn. We don't need to worry about less than or equal to. Where in continuous random variable we don't need to. In discrete we need to worry because 1, 2 no. We need to worry. In this we don't need to worry. Next. 0 less than equal to f of x less than equal to 1. We know the probability stands for 0 to 1. This is a given. Limit x tends to minus infinity f of x. If we are going to apply in place of x, if we are going to apply minus infinity, f of minus infinity answer is 0. The same. Limit x to infinity f of x. In place of x, apply infinity. F of infinity is equal to 1. F of infinity is equal to 1. Next, p of x greater than x. P of x greater than x, we can write 1 minus p of x less than or equal to x. This p of x less than or equal to x. P of x less than or equal to x is nothing but f of x. P of x less than or equal to x is nothing but f of x. 1 minus f of x. The same. P of a less than x less than b. F of b minus f of a. We have saw here also a less than equal to less than b equal to f of x into dx. A to b. F of x into dx, a to b. This C f of b minus f of a. If f is given, if cumulative distribution function or distribution function is given, we use this formulas f of b minus f of a. This is very very important. Using this one, we are going to do many sums. So if distribution function is given, what is the distribution function? Nothing but caps f of x. Caps f of x is given. When distribution function is given, this caps f of x nothing but cumulative distribution function or distribution function. If caps f of x given, then I need to PDF. What is PDF? PDF is nothing but small f of x. PDF is nothing but small f of x. If they given caps f of x, I need to find small f of x. The formula is small f of x is equal to f dash of x. If I going to differentiate cumulative distribution function, if I differentiate cumulative distribution function, I will get PDF, probability density function. So using this, we are going to solve all the sums in this exercise. Thank you.